For this video, we will look at rational exponents and how we can convert them into radicals. So first of all, we want to go with listing our rational exponent, which means a fraction is the exponent, and converting it into a radical. The denominator part is going to be the index of the radical. So it goes here on the radical, whereas the numerator becomes just the exponent. Now there is a second way to write it, which oftentimes might be advantageous to use, and you'll see in our examples, and that's where we'll just do the nth root of a. So we'll do the denominator as the index, and then put the exponent on the outside. We could use either one of these forms. One oftentimes is advantageous, as we'll see in just a moment. All right, so let's do some examples of just switching between the two. And when there's a number, I'll go ahead and simplify. Otherwise, if there's variables, we'll leave that later for simplifying. So for instance, if I have x to the 9/5 power, I'm going to take this 5, I'm going to make it the index, and then I'm going to write x to the 9th power as my exponent would be the 9, which is the numerator. The 5 becomes the index. Just convert it into a radical. Now, if I have, for instance, 25 to the 3/2 power, my recommendation is using the second form first because it's going to be easier to take the square root of 25, which we know, and then putting that result to the 3rd power. Now remember, if I don't list an index, that's implied to be a 2 as my index. So when I do this, I do the square root of 25 is 5, and then I put it to the 3rd power and get 125 for that. And then my third example, I'm just going to go start with the radical and I'll convert it into an exponent. So if I've got the 7th root of x to the 2nd power, notice that if I'm going to convert that into an exponent, that 2 becomes my numerator, the 7 becomes the denominator as part of that. All right, now let's just review over some operations also, some of our rules for exponents with operations, as well as how to simplify that. So let's start off with, for instance, x to the 1/5, and let's multiply that by x to the 2/9. Now let's go ahead and simplify this. When you're multiplying, you add exponents. So this is going to be x to the 1/5 plus 2/9. Now, we have to review over how do you add fractions. So over here, I'm going to do my work for it. 1/5 plus 2/9, I need a common denominator. So that's going to multiply this by 9/9 and this by 5/5. So I get 9/45 plus 10/45. So that gives me 19/45. Okay, and so for this 19/45, I'm going to go ahead and write that here on my other side here. We'll write that. So 19/45. So if I were to write this as x to the 19/45 power, now when I get that, that is one way to leave it if it doesn't say to convert it. So this would be my answer if I'm doing it in exponent form. If I convert it to a radical, I make that 45 into my index and the numerator as my exponent. So that would be what it would be when I convert it to a radical. Let's do one more example. Let's do x to the 2/3, and we'll put that to the 1/2 power. Now a reminder of the rule. This rule was when you multiply 2 with the same base, you're going to add the exponents. And then when we're adding fractions, we were reminded that we had to get a common denominator to do that. Here, when you're having an expression to an exponent, you bring it in, and if there's an exponent, you're going to multiply. That's our rule. Then you multiply those two together. So you're going to get, and when you multiply exponents, you multiply numerators and you multiply denominators. And so here we're going to have x to the 2/6 power, which reduces down to x to the 1/3 when you reduce 2 out of each of those. So this would be x to the 1/3 would be my answer if it's left in exponent form. If I were to put it convert it to a radical, the denominator becomes my index, so the third root of x to the first, and when we have an x to the first, we don't have to list the exponent. So just to note here, what we want to do is learn how to take exponential form, convert it to radical form, and convert it to exponential form, and use all the rules we have for exponents and radicals to help us with that process.